My project is on the effects of select hormone modulation therapy drugs on Parkinson's development. And here are the logos of the programs we're part of. So my introduction is, I was born in Phoenix, Arizona, of January 1996. My mom's side is from an area called Rampasture, Arizona, which is between Saley and Chinle, Arizona. And my clans are Maidishkijin initially, Tabang Bashishchin, Twitchidin Dashij, Latlana Dashanala. My father's family is from Ganado, Arizona. And I currently in the Bachelor's of Biology program here at Diné College. And I graduated my associates in general science back May of last year. And I'm currently in my third year at this bachelor's program. And here we go. So the background, I show, I found this picture at, I forgot what university it was. It was, but they show the symptoms and the drugs, that possible drugs to treat this condition. So as I say in this slide, in the United States, roughly 60,000 people are diagnosed with Parkinson's. It is the second most common neurodegenerative disease and is brought on by damage to the substantia nigra, section of the brain that is responsible for dopamine production. Conditions and symptoms brought on by the disease are debilitating and eventually cause death through disruption and decline of dopamine production in the human brain. The causes vary with patients, with genetics, head injuries, and even pesticide exposure being attributed to the disease. As of today, there are treatments available, but no cure. The current treatments include drugs like levodopa, which have numerous side effects, and eventually the drugs become less effective after years of use. And so my background is that my grandmother, she developed Parkinson's after we attributed it to a head injury. Nobody else would say why else she would she developed it, but she was the only one in our family to have Parkinson's. And I've seen firsthand what it does to a person, and I'd like to see if there's other types of drugs that can help deal with this condition. And next section is patients with certain types of cancers have a low risk of developing Parkinson's. Seen on a lot of research papers that I've read, and there's a lot of possible reasons why for that outcome. I believe that's possibly the drugs or treatments that involve, as they are an introduced variable and thus can have influence such risk. And breast cancer, as a result, is an area of interest due to the number of drugs used to treat it and how it is also a disease that increases risk with age, just like Parkinson's. And as and here in the slide, I show found this picture of comparison of non-Parkinson's patients or people without Parkinson's versus Parkinson's. As you can see with the substantia nigra, where it's completely gone in the Parkinson's patients, and that's that's the primary cause of why this disease begins. So the objective. Current objective is to find any possible link between breast cancer treatments like hormone modulation therapy and Parkinson's disease development with the female population of ages 55 and over. To achieve this, we use the treatment of breast cancer patients, with breast cancer patients either taking the drugs or not, and proceed to check on the groups after 3 years and check for Parkinson's development among those groups. And again, I show the picture here of the comparisons between the two types of, between the Parkinson's and person without it. So my roadmap, I could have cleaned it up a bit more, but as I showed the breast cancer patients through the Pearl Diver program, showed about 219,378 people with breast cancer. And my exclusion criteria include no prior Parkinson's, other types of cancer diagnosis, as they could influence the study. And then the inclusion criteria includes those over 54, it must be female, and that number came out around, it said 15,000, but it was actually needed just that. It was well over, I forgot the exact number. It's in the table 1. Excuse me. And the next part of the roadmap shows taking anastrozole and other hormone modulation drugs. Those are 33,099. And then from there, after treatment, see if there's a difference between those who develop the Parkinson's and those who do not, compared to the control. And here's my table 1 of the age demographics of breast cancer treatment groups, with a grand total of 2,311 in control. Nastrozole was 15,550, tamoxifen 7,185, exemestane 4,969, letrozole at 5,395. And there's their breakdowns according to age groups. The Pearl Diver only went up to age 80, because I couldn't get it any higher, so I left it at that. Any questions so far?
What was your criteria for a patient being included in this study,
Yes.
as far as enrollment?
Oh yes, I forgot to put my codes in. There was an extensive list of codes we used for inclusion in the breast cancer. It was through ICD-9 and ICD-10. At first we used for all breast cancer, including males, but then we filtered out with the age demographic as well as female.
And did they have to be in the enrolled in the database or in the healthcare system for a certain period of time?
Yeah, it was 6 months. I need to look back at that. I should have put that down. But yes, it was 6 months.
Before breast cancer diagnosis?
3 months
3 months before?
prior.
And how long after?
Yeah. 6 months.
6 months, okay. Right, thanks.
All right. Any more questions? Okay, I'm gonna start again. So I made with Austin's help, we had created a contingency table because during the coding for comparing the other groups besides Nastrozole, there was a coding error and we couldn't get the chi-square analysis done with the other treatment groups. And so we were stuck with the Nastrozole. And those are the numbers. The forest plot treatment effect, it was supposed to have multiple groups from the other drugs showing here with but it didn't work out so well. So we're stuck, like I said, we're stuck with the Nastrozole, and that's the only one that shows.
So what does this result mean?
We're just showing the Nastrozole's effect currently.
And what is the effect of a Nastrozole?
It actually increased well, it didn't cause anything, but there's an association with the increased Parkinson's development, as you can see from here. Those among those with breast cancer, no hormone modulation 107, Parkinson's within 3 years of enrollment, and then with those with the Nastrozole treatments, they went up to 658, but that might have been attributed to the larger number of people involved with the study, or the Nastrozole treatment right here.
Okay.
But it does show a higher correlation or a higher risk.
Okay, thank you.
All right. Statistical analysis. PRISM analysis with the odds ratio had produced a value of 1.487, 95% confidence interval of 1.213 to 2.967. With the value being more than 1, it shows that the outcome has a higher probability of occurring. This outcome. As a result of improper coding, not all the drug data was available or was shown irregularities, so we decided to go with the Nastrozole only. The only drug group that appeared normal was the Nastrozole, and that was decided to be worked on in the chi-square analysis in both Pearl Diver and PRISM. The PRISM numbers were selected, and they were added in the contingency table in the previous slide. As such, the data for Nastrozole did reveal a rise in Parkinson's development among those who took the drug. However, more research is needed to declare any causality. So the conclusion, as such, the data for Nastrozole did reveal a rise in Parkinson's development among those who took the drug. But again, more research is needed to be done. Numbers with the Nastrozole reveal that with the odds of it being random or statistically unlikely, with its p-value being less than 0.001,